This video is on rational expressions, and I'm going to call this video part 2. This video will focus on how to simplify rational expressions. So since our objective is to simplify rational expressions, let's just recap and make sure we know how to simplify fractions, rationals. So remember, this means that we have 8 pieces here. So pretend they're equal there. And here it says we're going to eat 4. So 1, 2, 3, 4. Well, that's the same thing as half. So that's what the word simplify means. It means we're going to rewrite it so it has the same value, it's just the numbers look simpler. So to do that, remember we divide out the GCF. So what can go into 4 and 8 is 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2. So if I have a pizza and I cut it into 2 slices, and I only eat 1, it's the same thing. So when you are asked to simplify with rationals, that's what you're doing mathematically, is just rewriting it in a simpler way. So when simplifying a fraction, you are dividing out the common factors. You're dividing out the greatest common factor. But if you don't start with the greatest one, so for example, if we take this example right here, I'm going to do it here so I have more room. If I need to simplify here, 15/35. So I need to divide out what the GCF is. So I'm going to break this down the way maybe you've seen it when you first learned how to simplify a fraction. So if I simplify 15/35, I'm essentially doing this. If I factor 15, I can factor 15 as 5 times 3. And I could factor 35 as 5 times 7. So what we're essentially doing is the 5's here divide out and make 1's. That's why we divide both of them here by 5, because 5 divided by 5 is 1 here. So we're just left with 3/7. So we're going to need to, here in a second, you'll see that we're going to need to factor our problems, and then we're going to divide out, because it's going to equal 1, if we have common factors in the numerator and the denominator. So keep this idea in mind here. Okay, and also another idea I wanted to go over with you. Remember, the denominator tells us we have 3 equal parts, and then the numerator says we're going to eat 3. So isn't that the same thing as, oh, we ate the whole thing? So when you have the same number in the numerator and the denominator, they divide and make 1. So the answer is 1. Well, that is going to happen. That's the exact same thing when we're working with rational expressions, when we have the variables. When you have the same thing divided by the same thing, it's going to always be 1. You see why in this example here without variables, and the same holds true with these ones that do have variables. So because it's the same thing in the numerator and the denominator, automatically it's going to equal 1. But here's another explanation of why. Well, 2 divided by 2, we know that that's 1. And then we remember from last chapter that we subtract the exponents, and 1 minus 1 is 0. Well, anything to the 0 power is just 1. So that's another example of why it's equal to 1. Everything's going to divide out and make 1. So when the numerator and the denominator are the same, it's equivalent to saying the fraction has a value of a whole. And again, why? You could see it easy here because there's whole numbers here, that it's equivalent when you have the same thing over the same thing as a whole. So same thing here, because remember, x represents a number. So if I told you here that x, I'm just making this up, But if I told you, get rid of that x, x is 5. So if x was 5, do you see how no matter what, you're going to have 1. If we knew what x is, it's going to always be 1, no matter what number you plug in for x. Okay, so that's the same thing here. 4x minus 5 goes with 4x minus 5. That's a binomial. They're together. And this one's 4x minus 5. So they are going to divide out and make 1. And again, if it's not clear to you why that is, plug in a random number. Pick whatever number you want. No matter what number, let's say we put 2 here. If we put 2, we're going to have 8 minus 5 and 8 minus 5, which is 3 over 3, which is 1. So that is why when you have the same thing in the numerator and the denominator, it's going to always equal 1. So keep that in mind. Okay, so we're ready to do some examples where we have variables here. So remember, we saw that in order to simplify a rational expression, you must completely factor before you can cross anything out, because they'll divide out. So again, remember that example that looked like this without variables, right? 15 is the same thing as 3 times 5. 35 is the same thing as 7 times 5, and so the 5s divide out because that's the GCF. Well, we're going to do that exact same thing here. So just like I factored here and then crossed out what they had in common, that's exactly what we're going to do here. So if it takes you a little bit longer to factor, I would pause the video, because my objective is not to teach you how to factor. So if you feel like I'm going fast, maybe pause it and factor the numerator and the denominator and then push play. So first, we need to factor this. And since there's a minus here, and x times x is x squared, and 3 times 3 is 9, the numerator can factor to x plus 3 and x minus 3. Now we're going to take the denominator, and we need to think of what multiplies to 3 and adds to -4. So we could have x and x, and then 3 times 1 makes 3, but -3 times -1 would make this -4 when we add them. So now we have factored. Okay, and now remember, because of the commutative property, we could also move this around, but it really doesn't matter. So we can cross out an x minus 3 with an x minus 3, and then we're left with x plus 3 over x minus 1. So if something has a plus or a minus, it's together. It can't be broken up. So we cannot do this. Oh, let's cross this out with this. That does not work, because we don't know what x is to be added with 3. And this one has to be subtracted by 1. So this is not x over x. These do not cancel. We cannot do that. So this would be our final answer. Now I'm going to show you how you could check your answer. We're saying that this is the same thing as this, that it's just a more simpler way of writing it. Just like we say that 4/8 is the same thing as 1/2, you could see they're exactly the same. So if I wanted to check this, I should be able to plug in whatever number I want for x. So I'm going to go with 2. And it should equal for both. So if I put a 2 here, 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 and here, let's see if we get the same thing on both sides. So here we would have 4 minus 9. So 4 minus 9 is -5. Here we would have 4 minus 8 plus 3, which is -1. And then we'd have -5 divided by -1 is +5. So we have +5 on the left side. Here we have 2 plus 3, which is 5, and 2 minus 1, which is 1, and 5 divided by 1 is 5. So I picked a random number. I picked 2 because I like 2, and we get the same thing on both sides. So if ever you want to know if you simplified correctly, you can take your answer and plug in a random number into the original problem and your answer, and it should equal the same thing, just like this equals the same thing. It's still half. 4/8 is the same thing as a half. That's essentially what we're doing here with the rational expressions. All right, let's take a look at this next example here. So the first step is we do need to factor. So I'm going to do the GCF first. 3x minus 8, there is no GCF. I'm going to put it in parentheses to remember it's together. And then we can only cross out if there was an x plus 2 and this was x plus 2. So there's nothing we could do here. That's it. It can't be simplified. It cannot be simplified, this problem. Even though I was able to factor the numerator here, nothing can be divided out. Nothing can be crossed out there. So I also want to make sure it's very clear that you cannot simplify in this manner. You cannot say, oh, 3 and 3, because it's not 3 and 3. It's 3x plus 6. So to cross out a 3x plus 6, we need another 3x plus 6. So you cannot do this here. You have to factor and then cross it out if it's identically the same. All right, let's go ahead and try number 9. It says, again, the directions here are simplify the expression. We cannot do this because it's not factored. It has a minus next to it. So we have to factor everything first. So first thing is there a GCF? Which, yep, it's 5x. Then here, the GCF of 5x squared and 20 is 5. Okay, and then here, nothing can be factored because we just have x minus 2, so it's going to stay the same. But this is a difference of 2 squares, so we could write it as x minus 2 and x plus 2. Alright, now that everything is completely factored, I can simplify an x minus 2 with an x minus 2, and then we can simplify a 5 with a 5. Now, notice that this 5 here has an x. It's a monomial. The only time you can't do this is, let's pretend the problem was like this. Then you can't cross those 5's out because the 5x plus 2 is a binomial. It's together. So you cannot do that. But in this problem here, the 5x here doesn't have anything next to it that's being multiplied. So that is why we're allowed to simplify these two 5's right here. So what we're left with is an x over an x plus 2. So let's just check one more, just to make sure we're on the understanding correctly here. So if I pick a random number for x, so you guys know I like to pick 2 because it's an easy number to work with. If I replace all the x's with 2, if this is indeed the correct answer, it should equal this side here. So first thing is exponent, so I'm going to have 4. And then 4 times 5. And then here I'd have negative 10 times 2, so I'd have 20 minus 20. So I would have 0 over, and then 2 squared is 4. 4 times 5 is 20. 20 minus 20 is 0. So remember we talked about domain in part 1 video. That was the bad number. So I said pick whatever number you want. But if it gets you 0 on the bottom, remember x can't be 2. So I just wanted to point out that you can pick whatever number you want, but you have to be careful because it can't make the denominator 0, which 2 does. So that was, even though I love 2, in this particular problem, that was not a good number. So I wanted to show you, you can pick whatever number you want, but if we were to have picked a number that makes this equal 0, which 2 would, it gets undefined. So let's pick a different number like 3. So I'm going to go ahead and plug in 3. So we'd have 3 squared is 9. So 5 times 9 is 45. minus 10 times 3 is 30. So we'd have 5 over, and then we'd have 9 times 5 is 45, minus 20, which is 25, and 5 over 25 is a fifth. Now we're going to do the same thing over here. We'd have 3 over, 3 plus 2 is 5. So I had an error right here. I just want to point out this should have been 15. 45 minus 30 is 15. Anyways, so we'd have 15 over 25, which is 3/5. And then here we'd have 3/5, so it equals. So we would know that this is the correct answer. So again, remember we were not allowed to plug in 2 because it would make the denominator 0, which would make it undefined. Okay, so let's go ahead and simplify this one. So first of all, start with the numerator. The GCF is 2x to the 4th. Then now that we have 2 terms, we can't go any further. We know automatically if the highest exponent is a 1 and nothing goes into 3 and 5, that's completely factored there. Now here, what can go into both of these is 4x squared. And again, this is completely factored too, can't go any further with 2x minus 1. So this can't cross out with that. They are not the same binomials. So we're going to have 3x minus 5 and the 2x minus 1 stay there. But then here, 2/4 is the same thing as 1/2. So the 2 and the 4, the coefficients, we simplify just like normal. And then remember from last chapter that when we're dividing, the rule is to take the top exponent, subtract the bottom exponent, and that is why we have x squared. And we don't need to put a 1 in front of a variable. It's fine if you do, but it's not necessary. And this would be our final answer here. Now remember also, if you're visual, that this is saying here that you have x times x times x times x up here. And then here you have x squared. And then those would make 1 and those would make 1, and you have 2 left on the top. So remember, you are allowed to simplify this front part here because they are monomials. But these ones you cannot do this. You can't cross that x with that x because they are connected together. They're a binomial here. Okay, so let's go ahead and simplify this one. So first thing is there is no GCF. There's 3 terms. So we need to think of what multiplies to -12 and adds to -1. So again, feel free to pause the video as you factor the numerator and the denominator. So we'd have 4 times 3 is 12, but it has to multiply to -12, so I'm going to have -4 and +3. And then here we have cube, right? X times x is x cubed, and 3 times 3 times 3 is 27. So I call this the SOAP method. So S-O-A-P. So S means keep it the same. O means opposite of this one here. And then AP means always positive. So we're going to take x, and we're going to take 3. And then we say to ourselves, square, together, square. So we're going to take this and square it. So x times x is x squared. And then we're going to put them together. So 3 times x is 3x. And then we're going to square this one. So 4 times 4 is 16. So now we have x plus 3 times x squared minus 3x plus 16, which this cannot be factored further here because there's nothing that multiplies to 16 and adds to -3. So that's how we know that can't be factored further. So we can cross out x plus 3 with x plus 3 because they are essentially dividing out and making a whole. So all we're left with is x minus 4 over x squared minus 3x plus 16. And that is our final answer there. Nothing else can be divided out. All right, let's take a look at this example here. So first of all, is there a GCF here? I'm thinking no. So then we're going to multiply. Since it's a trinomial, we need to think of what multiplies to negative 60, but adds to 11. So it needs to add to a positive. So I know the bigger number needs to be positive and the smaller number needs to be negative because it has to multiply to a negative, and the bigger number is always this sign right here. So if we add these now, we're trying to find what adds to 11, and this would work. So we're going to have 6x, 6x, and then we have negative 4 and positive 15, and then remember we're dividing out like they were fractions. Both of these 2 can go into 2 can go into 6 and 4, so it would become 3x minus 2, and then what can go into here is 3. So then we'd have 2x plus 5. So now we have successfully factored the numerator. Okay, now we're going to go ahead and factor the denominator here, and first thing is check if there's a GCF, which there's not, so we're going to go ahead and group. So the GCF of the first two numbers is x squared, and then the GCF of 6 and 4 is 2, positive 2, 2 times negative 2, and then we're going to go ahead and put the x squared and the positive 2 together, and then 3x minus 2. So then this cannot be factored further because nothing multiplied by itself is x squared or 2, plus there's a plus in between, so we can't. We cannot factor this one further. So now anything we see in the numerator we can cross out in the denominator here. So a 3x minus 2 with a 3x minus 2, and so we're left with 2x plus 5 over x squared plus 2. And that would be our final answer. Alright, lastly, let's look at this one. When the terms are close, so when you look at this and you're like, wow, they almost look the same. They both have a y and they both have a 2, even though they're opposites. So when you should notice that you're simplifying and you see, oh, this is positive y, this is negative y. And this is negative 2 and this is positive 2. When you notice that they're both opposites, so when the terms are close to matching but differ by a negative, factor out a negative from one of them. So pick one of them to keep the same. So I'm going to have y minus 2 stay the same. But here I'm going to take out a negative here. And you could put a negative 1 if you'd like. So remember when you have a negative outside the parentheses, it makes everything inside opposite. So you would have, instead of a negative y, a positive y. Instead of positive 2, a negative 2. So make sure you understand why that works. A negative 1 times y, negative 1 times y is negative y. That's what this has. And then a negative 1 times negative 2 is 2. And that's what we have right here. So we have not changed anything by writing it in this manner as we have here. So now this will match with this and they will divide out, leaving us nothing in the numerator, so we could always put a 1, because these make 1, and then a negative 1, or a negative on the bottom, and then a positive divided by a negative is a negative. So if you would add this one onto your notes on the side, I'll also know that you took the notes and watched this video, because you will have this one written in addition to number 13. So if you write this down and you're asked to simplify this, and you should notice that this is positive and this is negative, and this one's positive and this is negative, that's how we know we can apply what we're just talking about right here. So I'm going to keep this one the same, and then I'm going to put a negative on the outside, and a negative 1 times 3x is negative 3x. A negative 1 times a positive 2 is negative 2. And then these are going to simplify to make 1 over 1. So we're left with 1 over negative 1, which equals negative 1. So look out for that. When you have two binomials or two polynomials that look the same, but their terms are all opposite like that, if you factor out a negative, then this will happen here. They'll match up. So we have talked about 7.1. You can log into your online homework and do all the homework for this section, except for when you get to the problems that look like 14, 15, 16, and 17 in your notes, which are multiplying and dividing with fractions, with rationals. Skip those ones. But you have enough knowledge to do all the ones that say domain and range, evaluate, and now simplifying. So please start your homework.